we will like to discuss the question number 142 from mechanical engineering set A paper. So in question number 142, it is the statement 1 and statement 2. So the reasoning and assertion and reasoning type questions. So in this particular one, where you have given the first statement, the statement 1 as. So if you go with the statement 1, so the statement 1 says, resonance is a special case of forced vibrations in which the natural frequency of the body is the same as the impressed frequency of the external periodic force, whereby the amplitude of forced vibration peaks sharply. So what is exactly this particular one is, if you have any system subjected to an external force, where the external force is applied with certain magnitude, amplitude, with some frequency, let us say is omega t. So now omega is the applied frequency here. If you go by this, omega is applied or forcing frequency, whereas the natural frequency of the system depends on its parameters, so which is square root of k by m. So if I define the value of some undimensional parameter omega by omega n, so what is exactly resonance is? So if we want to find the resonance, so resonance is the case when the omega is equal to omega n. When omega is equal to omega n, now the system gets its dynamic amplitude. If I give the amplitude of this as x is equal to a into cos omega t minus some phased angle. So where a stands to be the dynamic amplitude. So dynamic amplitude is generally given by xs divided by square root of 1 minus q square whole square plus 2 zeta q whole square in this particular way. So what is exactly he says is, when q is equal to 1 or omega is equal to omega n, let us say when there is assumed to be there is no damping, so this will become a is equal to xs is equal to plus or minus 1 minus q square. When q is equal to 1, the dynamic amplitude becomes infinity without the damper, and with the damper again it gives to infinity. So as per as statement 1 is concerned, resonance is a special case of forced vibration in which the natural frequency of the body is same as the impressed frequency of the external periodic force, whereby the amplitude of the forced vibration peaks sharply. So therefore at q is equal to 1, so a becomes infinity. So this is what we call it as the resonance, and as per this the first statement happens to be correct. Now again going for the statement 2. So as per the statement 2, it says the amplitude of forced vibration of a body increases with increase in the frequency of the externally impressed periodic force. And if you go by this particular one, for the same case which we are discussing here, so if I try to draw the a by xs plot for different variations, which is equal to 1 by plus or minus 1 minus q square, and if you try to see this particular variation of q with respect to this value of a by xs, so which shows a clear cut in this particular one. So in the initial stages, so the value peaks up, and at q is equal to 1.0, it reaches to a very peak value or infinity. But as the q increases, and if it is beyond root 2, the value decreases. That means there are two zones clearly in this particular one. One zone starts from 0 to root 2, where the a by xs increases with increase in what you call it as q value, but if it is q is greater than 2 root 2, so a by xs decreases from this particular one. So now if you look at the statement 2, the amplitude of forced vibration of a body increases with increase in the frequency of the externally impressed periodic force. So as such the statement is not valid in the entire range. Only in one particular range it increases the frequency or increases the amplitude, and beyond root 2 it reduces this. So we cannot say that it is the correct statement because it is not valid in the entire range. Maybe in one range it increases, but beyond that it increases. And generally when we are designing, we design the systems only in this particular zone. So obviously statement 2 is a wrong statement. So in this particular one, so statement 1 is correct statement, whereas statement 2 is a wrong statement. So as per the options goes, it is the option is, it is a first the option for this particular one is answer C. So which says statement 1 is correct, but statement 2 is false. So this is what is required for this particular one. Thank you.